Hi everyone, this is AKD sir in the channel Classes with Learn. In continuation with our topic of sequence and series, this is part 3. So let us take some more examples on GP that we had continued. The first question is from the IIT or JEE exam 1964. Let modulus A less than 1, that is say lying within minus 1 and plus 1. Modulus B is less than 1 and consider the infinite GPs. X is equal to 1 plus A plus A square plus dot 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 up to infinity. Y is equal to 1 plus B square plus dot 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 up to infinity, and Z equals to 1 plus AB whole square plus dot dot dot. Then what is Z? This is your question. There are 4 options: option A, option B, option C and option D. Now to answer it, first let us find what is X. X is equal to 1 plus A square plus dot dot dot, and that as per the GP's infinite formula 1 upon 1 minus A. And from here we can find out A is equal to 1 minus 1 upon X. Likewise, Y is equal to 1 plus B square plus dot 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 up to infinity terms, that equals to 1 by 1 minus B, and B equals to this way becomes 1 minus 1 over Y. Likewise, Z equals to 1 plus AB whole square plus dot 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 this way, and that equals to 1 over 1 minus AB. Now why did you place the value of A and B that you have found out it earlier? So press it and we just solve it, and after you have solved it, the result becomes option C. So this was the question, very easy one. Next question, this is from the IIT 1967 JEE exam. The sum of the first P terms of an AP is Q, and the sum of the first Q terms is P. The sum of the first P plus Q terms is, there is also 4 options, okay, and you have to select the correct options after you have worked it out. So let us answer it. Let A plus D, A plus 2D, etc. be in AP. Therefore, as per the formula of AP summation, SP is equal to it is given, or that P by 2 2A plus P minus 1 whole into D that equals to Q. Let it be question number 1. Likewise, SQ is equal to P, that is Q by 2 whole into 2A plus Q minus 1 into D. This is equal to P. Copybook style sum, Now, if we subtract 2 from 1, that is by the operation 1 minus 2, you get this thing P minus Q by 2 whole into 2A minus D plus D by 2 into P square minus Q square. We can minimize both the sides, that equals to Q minus T, okay. We can minimize both the sides from both the sides P minus Q, supposing that P not equals to Q, that is P minus Q not equals to 0. This way it becomes 2A minus D upon 2 plus P plus Q into D by 2 is equal to minus 1. That is, you get 2A plus P plus Q minus 1 whole into D is equal to 2. Let it be question number 3. Now, S of P plus Q is equal to this thing P plus Q whole by 2 whole into 2A plus P plus Q minus 1 into D. Ask whether you have found out this value, and just press the value and you get that S of P plus Q is minus P plus Q. Therefore, the option lies with the option C, and that is your answer. So going to the next question, this is from IIT JEE 1968. Let S be the sum, P be the product, and R the sum of the reciprocal of n terms of a GP. Then there are 4 options and you have to choose the correct options. So let AR square dot dot dot, that is up to n terms, be the GP. Therefore, S is equal to, the formula A whole into 1 minus R to the power n upon 1 minus R. The reciprocals of the GP, naturally it will be 1 by A, 1 by AR, 1 by AR square and so on. So the sum R equals to 1 by A whole into 1 minus 1 upon R to the power n by 1 minus R. Therefore, this is coming up to this thing, and it is 1 by A, 1 minus R to the power n whole upon 1 minus R into 1 by R to the power n minus R. Simple simplification. Therefore, S upon R, we are dividing S with R. So this becomes S square into R to the power n minus 1. That is equation number 1. Now P, the product. Product will be A into AR square, this way into R to the power n minus 1, then a term. And this comes up to A to the power n. There are n number of S, therefore A to the power n into R to the power. This will all be powers be added, 1 plus 2 plus up to n minus 1, and this becomes A to the power n into R to the power n into n minus 1 upon 2. Therefore, p square, you are just squaring it up. P square is equal to a to the power 2n into r to the power n into n minus 1. And that equals to a square into r to the power n minus 1 whole to the power n, and that equals to s upon r whole to the power n. So by 1, you can get that s is equal to r into p to the power 2 by n, which is the option D. So option D is the correct answer. Next, let us go to another sum. This is also from the IIT JEE 1973. What is this? After striking the floor, a ball rebounces to 4/5 of its height from which it has fallen. From which it has fallen, it has come up to 4/5 of that height. If it is dropped from a height of 120 meter, initial height, okay, the total distance it travels before coming to rest, gradually it will be lesser and lesser in height, In meter is this, 4 options are there. Now let us do it. So if it is height from a height of h, say, though it is given 120 meter, later would be placing the value of h as a 120 meter. It rebounds to a height of 4/5 h. Then it falls to a distance of 4/5 h and rebounds to 4/5 whole square into h, etc. this way. Therefore, the total distance is traveled is equal to h plus 4/5 h into 2 times because it is fallen and come back to that. So this is that. It's an infinite GP, Therefore, the infinite GP formula, you get the sum. So the sum is h whole into, I have taken the h as common, 1 plus 2 into 4/5 plus 2 into 4/5 whole square, etc. This one part you keep apart, and this is an infinite GP of which the first term is 2 into 4/5, and this way this is the sum of it. And it, after simplification, comes down to 9h, and h is given 120 meter. Just you multiply h 120 meter with 9, and you get the answer 1080 meter, which is natural option number C. Now let us take another question from IIT JEE. This was placed in 1974. The question is, the sum of first 10 terms of the series 6 plus 6, that is 66 plus 666 plus ... this way it will go on. Okay, the first 10 terms, mind you, and that will be equals to the 4 options are there, you have to select the correct. So what you have to do, that is to first arrange it. Why didn't you take this 2/3 common? So this way, within the bracket it comes 9 plus 99 plus 999 plus ... up to 10 terms. That equals to 2/3. Now why didn't you, write 9 as 10 minus 1, 99 as 10 square minus 1, 999 is 10 cube minus 1 plus this way. So this will be constituting a GP, 2/3 whole, 10 plus 10 square plus 10 cube, and a minus 1. How many times of minus 1 are there, How many times? There are n times of 1, that is why it is minus n. Therefore, 2/3, the first one is on GP. So 10 into 10 to the power n minus 1 by 10 minus 1, have minus 1. So this is equal to 2/27 whole into 10 to the power n plus 1 minus 10 by 9, that 9 I have taken outside, 2/27 it becomes, and minus 9. So that is the option D. Now, a very interesting part of that, the recurring decimal. I have written that recurring decimals furnish a good illustration of an infinite GP. In your lower classes, you have learned how to represent this recurring decimal, arithmetically you can solve it. It can solve it. But now we are solving this by taking help of the infinite GP. So 0.62323 recurred. That will be 0.6232323. This will be going on recurring. So this can be written as 6/10 plus 23/1000 plus 23/1 lakh, and this way. So this is 6/10, and from the next portions I have taken 23/10 to the power 3 as common. So the first one is 1, then it is plus 1/10 square plus 1/10 to the power 4, and this way. So this is 6/10 plus 23/10 cube whole into, this is an infinite GP, the first term being 1 upon a minus r. So 1 minus 1/100, that is 1/10 square. So this way it becomes 6/10 plus 23 by 10 cube into 100 by, this is solving, simply by solving, you get 100 by 99. Then you just simplify it, 6 by 10 plus 23 by 990, and this way it becomes 617 by 990. That is tallying with the answer if you solve it arithmetically, that you have already done in your earlier classes. Okay? So this is all today, my friends. If you like my channel, I request you to subscribe, share and like. Thank you all.